And I'm Zach Sutton.
And we are going to be juniors at the Academy of Allied Health and Science.
And today we are going to be introducing to you our physics project that we've been doing since the start of the summer. This all started because we both play sports. She plays softball and I play soccer. And we were both interested in how acceleration plays a part in each of our sports. So we devised a project where we would make an accelerometer, or a device that measures the acceleration of an object. And then we would use this accelerometer on different objects in different environments to retrieve data and then use this data to make puzzles for viewers like you to figure out.
So what is acceleration? Acceleration is a vector that represents the rate of change of velocity of an object. A vector, such as acceleration or velocity, includes both magnitude and direction. For example, the vector velocity is the speed at which an object moves in a certain direction. Therefore, acceleration is the change in speed and/or direction of an object. Furthermore, Newton's first and second laws of motion include acceleration and are applicable to this project. Newton's first law is that an object in motion stays in motion unless acted upon by an external force, meaning that when you're moving and you're not increasing speed, slowing down, or changing direction, there is no net force acting upon you. This leads into Newton's second law, which is defined by the equation F equals ma, or force equals the mass of an object times its acceleration. So now that you guys have a bit of background, we're going to go into the details of how we built our accelerometer and what we used to build it. Okay, here's our accelerometer and an old phone that we used to download the data. Our main goals were to create an accelerometer that can record acceleration data many times per second, is battery powered, and does not require any cables. So let's open it up and see what's inside.
So what this is here, this is a 9-volt battery that we just had at the house that is being used to power this whole contraption here. Then there's this switch here, which will turn the accelerometer on. When we turn it on, you can see that starts lighting up there, that red light's blinking, and this green light is turned on, meaning that everything is powered up. What this also means too is that over here on this device, we can connect the accelerometer to the phone, and now you can see it's connecting. Now all of this data from the accelerometer is coming into here. Now all of this data is pretty constant because the accelerometer is not moving much, but when I lift it up, you can see some of the data points change. I'm moving it back and forth, and the data points change. Then we press this button again, and it disconnects. Next, we have the circuit or breadboard. So this is the place where the accelerometer itself, the accelerometer chip, is sitting on, and this also helps us connect all the wires for transmission and energy.
So we used the Arduino Nano 33 BLE because it has a built-in accelerometer. It also has Bluetooth, but the Bluetooth is too slow to use for our purposes, and we needed to find another Bluetooth solution.
So this is the Arduino Nano here. You can see all of these wires going to and from the Arduino Nano, which gives it power and also helps us transmit signals that are being that are going through it and out of it. Next, we have our Bluetooth chip. We used an HC05 Bluetooth chip because it is inexpensive, has fast transmission, and is easy to connect to my old Android phone.
So this gives you a brief introduction to our accelerometer. We'll create a separate video that details the actual wire connections, programming, and connecting to the phone. We'll also discuss some of our lessons learned about processing the data and the concept behind how the accelerometer actually works.
So when we put the black case back on, and when we screw it on, it will be like this, and we can attach it to certain places, and when it is moved around, the data will show up on the phone. So to recap with what we're going to be doing for this project, first we're going to record an activity using the accelerometer. Then we're going to take the data that we collect from the accelerometer and put it into a graph form to make it easier to see. And then taking those graphs and putting in some visual aids, we're going to create puzzles to show you guys, the viewers, and try and have you solve those puzzles and figure out what we did. But before we do that, let's look at two tests and evaluate them together.
Okay, so for the first test, we attached the accelerometer to a string and we had Zach spin it over his head and to his side. And we took a video of that, and this is what it looks like. Okay, so we took the data from the accelerometer and we put it into a graph form, which is what you see here. And we also took a picture of the accelerometer itself with the different axes labeled with pieces of tape, the blue representing the positive x-axis, the red representing the positive y-axis, and the yellow being the positive z-axis. And then that would correspond to the lines and colors on the graph over here. So in the graph, you can see the different parts of it, this being when Zach was spinning it above his head, this being when it was resting next to his leg, and then this part being when Zach started spinning it next to his side. We also have to take into account that the accelerometer is measuring the gravity that's acting upon it at all times.
For example, in this spot here, you can see that the red line here is all the way at 0 over here. But these other two lines are not at 0. In fact, they're at 1 or near 1. This is because the accelerometer is sensing gravity. When the accelerometer is lying still, the accelerometer reads it as if it is accelerating upward at the acceleration of gravity, or 1g. The axis that senses this gravity will depend on how the accelerometer is oriented. In this case, the blue axis is pointing nearly upward, and the accelerometer is sensing that it is accelerating 1g in the blue direction, even though it is at rest. Now, we also have to look at this part here too, because we can see here, other than some peaks and some troughs that are irregular, for the most part, this is a more constant graph. And what that means is that when the string is spinning around above my head, that the acceleration is not necessarily changing in speed, but rather that the direction is always changing. So to make that a little simpler, the accelerometer isn't moving above my head any faster the more I spin it, but it's changing direction at a relatively constant rate to keep it moving in a circle. This is called centripetal acceleration. Now finally, we can see over here that these peaks and troughs are very high and very low at some points. And this is because I'm spinning it to my side where the accelerometer is going up and down. Now, these peaks and troughs of the blue here and the yellow are basically meaning that at some points, like for example, when the accelerometer is down by my side when I'm swinging it, that gravity is pushing down on it, but the tension from the string, is pulling it back up. So the forces are somewhat equal in that respect. But when the string goes above my hand and the accelerometer is above me, gravity is pushing down on the top of the accelerometer, but there's no tension from the string to push back. So we get the really high peaks and the really low troughs from that. Now, as for our second test, we put the accelerometer on the dashboard of a car and started driving around the block that you can see over here, and we collected the data from this. So you can see on the graph right here, in the legend, we've got the blue is forward and backward acceleration, and the left and right, and the red is left and right on this graph. So how we started is we started in the driveway here, and we made a left out of the driveway and started driving down the street this way. You can see a little bit of that here. Next, when we got to the end of the block, you can see that we made a left turn to go here, and then another left turn to go around the block this way. Over here on the graph, this corresponds to the turns made over here. As you can see, the red, which represents the left and right acceleration, is peaking definitely down here towards the bottom and is going negative. This means that the accelerometer was picking up a left turn instead of a right turn, which would have been positive. We can also see with the blue line that this is also going down too and becoming negative, which means that the car is decelerating when it gets to a corner so that we can make the turn. After making this turn over here, we come back and we're moving down the street. As you can see, there is a slight right movement here, but we're still going straight a lot. So you can see here, the blue line for forward and backward acceleration is going up, which means that we are accelerating faster, moving faster down the street at this point. But the left and right acceleration is moving a little bit. As you can see, we started at more of a left position, but then made a right position to come down the street like this. Once we got to the end of the block, we ended up making 2 more left turns, which you can see represented on the graph here. The red graph is going very negative because we're making left turns, whereas the forward-backward acceleration is also going negative because we're slowing down into the turns. Eventually, when we get to this point, you can see on the graph here that we pulled into the driveway and stopped, which would be over here, so that we could turn around and go back the other way. When we start going back the other way, we can see now that the graph is changing. This means that instead of making a left turn like we were down here, we're making right turns now. And this is corresponding to the red spikes you can see here. However, the blue graph isn't changing all that much because we're accelerating, almost getting to the turn, but once we get to the turn, you can see that the blue is going negative, which means that we are slowing down to go into the turn. Then, once we get back to the same spot over here on the block, you can see that the signs have flipped here because we are originally starting in a left position, but then we're also moving more into a right position, so it's staying. Finally, once we get down to this part of the block, we're making 2 right turns again, which is signified by the red spikes here and also the blue troughs down here that are going negative. Eventually, once we get down the block again, we turn into the driveway, which you can see here is a right, and we're also slowing down immensely so we can get into the driveway without going through the garage.
This test is a good reminder that acceleration is different than velocity. Our graphs show speeding up, slowing down, and changes in direction. They do not, however, show the actual speed of the car.
And now for what you've all been waiting for, the first puzzle. So this one is called Mystery Drive number 1 because we put the accelerometer in the car and drove to a certain location in the town that you will have to figure out. So first, we've got the map of town. Now, we don't have a set starting part, so that's going to make this a little bit harder, but all the more challenge, right? So over here, you can see a blown up map with a bunch of different locations, and you can also see this dotted box here. This is just a close-up of what that box looks like, just because it's kind of hard to tell what it looks like in here. So you'll have to figure out where we started from, first of all, and you'll also have to use the graph on the next slide to identify turns, stops, starts, etc., and eventually determine what location we ended up. So now we've got the graph. Up here, you can see this is labeled forward/right, which means that any peak that shows up in this area is going to be either forward or right, depending on the graph. So, for example, this part here is going to be a moving forward because it's a peak up in this top area, and it's also the blue line, whereas this one would be a right turn because of the red line. Now, the same thing is true down here with backward and left, meaning that the blue line going down here means backward, and the backward or stop or slowing down, and red down here would mean a left turn. So now that you have all your data that you will need in order to find the certain location, you can pause the video here if you want to, so that you can get all of the different pieces of information and determine where we started and where we stopped.
Thank you guys for watching this video. We hope you found it interesting. Tune into the next video to find out the solution to that puzzle. Good luck!
Good luck!